Hello, everyone. This is Francesca Vigliani from Cloud Academy. Thank you for joining us for episode number 3 of our Pandas Like a Boss webinar series. It is so great to see so many of you connected to this session, and I feel like I also see some names that I recognize from the previous 2 episodes, so welcome back, and thank you for joining us again. Before introducing our speaker, just a few housekeeping announcements. I'd like to remind you that this webinar is being recorded and will be shared with you via email. During the webinar, we will leave time for your questions, so feel free to add them in the chat box and our expert will try to answer them during the final Q&A. Lastly, we hope you had time to set up the environment so that we can get going with the session, but if you had problems, don't worry, you just need to have the data on your Google Drive, and Andrea will show you how to read the data from that source. Okay, I'm all done with the announcements, so without further ado, let me introduce you to our data scientist, Andrea Giussani.
Thank you, Francesca, and welcome everybody. Nice to see so many people even today, so thank you for participating at first. Just a brief introduction of myself. I'm a data scientist here at Cloud Academy, where I mainly focus on the development of machine learning algorithms to provide state-of-the-art solutions to improve the quality of our product. You can reach me out on LinkedIn, or you can visit my website for updates on machine learning or Python in general. All the details can be found in the webinar-specific GitHub repository, and the URL is provided in the registration email as well. There I will also upload the full transcript of this live demo as soon as we finish the session. So just check it out there if you're curious. The agenda goes as follows. We're going to recap what we did last time, and then we jump into today's webinar topic. So this is the third episode of our Pandas series. I hope you have enjoyed the previous episodes, in particular the last one, where we have understood how to manipulate different data frames. And in particular, if you remember last time, we have seen different techniques and methods to manipulate data frames, moving from the concat method to the merge one. And we have also explored the explosion technique, which might be useful in case you have an iterable as value in your data frame. If you have missed that, don't worry. The webinar is publicly available on the Cloud Academy YouTube channel, and you can find the details in the registration email. Today's topic is the natural consequence of the previous episode, since we are going to explore methods that allow you to transform your data source. In particular, we are going to take into account 4 main Pandas functions that allows you to perform the manipulation and transformation that you are interested in. So at first, we are going to look at the pivot method that allows you to express data with respect to a set of indexes and columns. Secondly, we are going to explore the unstack method, which basically perform the same operation as the pivot one, but with a multi-index data frame. Third, we're going to look at the pivot table method that is useful when one wants to compute aggregate measures with respect to a set of indexes or columns. And finally, we are going to understand and investigate the group by method, which is basically a more flexible approach to the pivot table. As for the environment, we are going to use Google Colab to perform each single live session. It's not mandatory, but it's strongly recommended. I have written a README on how to set up a Google Colab notebook if you're not familiar with it. And I assume that you have read and set up the environment already, since all instructions were provided before the start. As for the data, we're going to take into account 2 data frames that contain the time series of Amazon and Tesla stock, respectively. And in particular, we're going to take into account the series of the closing price and the corresponding daily value. If you have already attended any webinar of this series, you should be familiar with this kind of data set, since we have already used those in the second episode. So without further delay, let's jump into our Colab session. I have opened already a Colab session, so please be sure that you have a similar one on your local environment. And as usual, what we have to do is basically mount our drive inside the collab session using the Google Colab API. So basically, I'm going to import drive, and I'm going to mount the drive inside the Google Colab session. This command is standard, and possibly you will be asked to provide some authentication steps in order to allow Google to access to your drive. And the procedure is pretty easy. You just need to perform a few authentication steps that you see here on my screen. And then when you get here, you just copy and paste. And that's it. So with this simple instruction, we have mounted our drive inside the Colab. And well, now we are ready basically to perform all the analysis that we wish to perform. And if you pay attention now, on the left, you have a folder named Drive, where you can find all the details and all the folders that are inside your drive. So that's it. Again, so since we're going to use Pandas, I'm going to import Pandas as with the standard convention PD. And if you have followed the instruction, I strongly suggest you to basically to put all the data inside a folder. In this case, I call CR webinars, and I'm gonna pick the data in this folder called data. And obviously, your path will be different from mine because we are working in different space. So as I said, we are taking into account two data frames, one related to Amazon and one related to Tesla stock. So I'm going to read those files using the Pandas read CSV function. And therefore, I'm going to use the read CSV. And if you pay attention, I have basically put a string standing for the path where the read CSV function is reading the file. And then I can also add a few other arguments. I have explained last time, for instance, I'm going to set the index call equal to 0, meaning that we're going to take the first column of our data source, and we're going to set that as index of our data frame. And we repeat this not just for Amazon, we do this also for Tesla. So I store the Tesla data frame into a variable called Tesla df, and this is nothing more than the read CSV application using the Tesla data that you can find obviously on your drive, and we set the index equal to 0. So we run this. There is no, possibly it's called Tesla. Let me check. Sorry for that. Okay, it's just typo here. Here we go. So we got all the data in our working memory, and let's try to investigate, for instance, the type of the columns we are dealing with by applying the info method on the Amazon DF. And if you pay attention, we have 4 columns, namely date, close, volume, and symbol. And the date is of type object. Last time, if you remember, we forced that column to be a datetime object using the Pandas toDateTime function. But as I said, at every single webinar, I'm going to try to give you new tips and tricks related to this read CSV function. And the today's tips goes as follows. We can actually try to parse the data directly in the read CSV call, by using the argument parse date. And this requires actually to specify the column you wish to have as a datetime in your final data frame. In our case, it's date, but you can even pass multiple columns if you have more than one column related to date. In our case, it's just one. And you just need to apply this to both data frames, namely Amazon and Tesla. So we run again the cell. And if you now inspect the type of the columns, not surprisingly, we get that the date now is a datetime, thanks to the fact that we parse the dates inside the read CSV function. So this is quite a nice tip, and I strongly encourage you to try to use it for your local and personal projects, because it's useful. You know, it just with one single line of code, you have produced a data frame and you have forced the date column to be a datetime. Okay, so last time, if you remember, we concatenated the two data frames, namely Amazon and Tesla, using the concat method. And again, we are going to do the same now. We're going to concat the Amazon df and the Tesla one. And in particular, we are going to sort the values with respect to both the dates and the symbol. Again, we have already covered this code in the last webinar. So if you have missed that, I strongly encourage to follow offline the recording. And we also specify ascending it to false, meaning that we are sorting the values from basically the most recent date, so that it's more readable. Namely, let me say like this: if this would be set to true, then you would sort the values from the grid, from the most recent. Otherwise, in this case, we are picking we are deciding to have a data frame that has rows ordered by date without us specifying an ascending order. And then you are going to reset the index. And in particular, we set drop equal to true, since we are not interested in bringing the original index inside the new data frame. And I'm gonna call and I'm gonna store this into a variable called df. And just to give you an idea, this is the result of this very clean code that we just wrote in this cell. It's a data frame that is ordered by the date and and by symbol. So actually, with ascending equal to false, as I said, we are going to basically order the data frame from the most recent, but possibly if you set this equal to true, it's gonna order the data frame with respect to the bottom dates. And in particular, for the symbol, is going to take an alphabetic order, and therefore ascending equal to true means that the ordering is made from A to Z. Okay, so let's jump into today's topic, which is a transformation of such kind of dataset. This dataset is typically called a tidy dataset, since each single row represents a unique observation. And therefore, we can reshape that, and a better representation is one in which you have a data that is set as index of the data frame, and as columns the symbols of your data frame. And to perform such transformation, you can use actually one very interesting method inside Pandas, which is the pivot. So the first method that we are going to look together is the pivot one. And the pivot actually is pretty useful, since allows you to move actually values, row values of a specific column in our case, for instance, symbol, as columns of the data frame. So suppose that you have to perform a report, and the report asks you to write down a CSV file in which you have, for each single row, a trading day, and the columns are basically the stocks of your portfolio. And the values on that file is nothing more than the closing price. So to produce such a table, you can employ the pivot from Pandas. And the pivot requires, as you can see from the help, requires at least 3 arguments. The data, actually, which is nothing more than our data frame. The index, which is nothing more than the column from the original data frame you wish to have as index of the new data frame. In our case, is the date, since we want the new data frame to have granularity with respect to the trading day. And then we have a columns argument, in which you can specify basically the column from the original data frame you wish to have as columns of your new data frame. In our case, as I said before, is the symbol. And finally, the most important one is the values. The values actually is interesting, since is nothing more than the column that you wish to represent inside the new data frame. And for instance, as I said before, I want to have a data frame in which I have as granularity, raw granularity is the trading day. The columns is nothing more than each single stock in your portfolio, and then as value, the closing price. Therefore, here I'm going to fill the string as the close column. And finally, I'm going to sort the values, sort the index, sorry, since I want that table to be sorted with respect to the date. And I store this into a variable called pivot_df. And just to give you an idea, I'm going to print the first 10 rows of the new object. Here is the result. Remember, we started from a data frame that looks like this, namely a tidy data set where each single row represents a unique observation for a specific date and symbol. Here instead, it's a quite different way to express your data, since if you pay attention, you have as index of the new data frame the date, not surprisingly, since we have said this. And then a symbol, you have just exploded basically the values of the symbol column in order those values to be columns of the new data frame. And the values that you see here inside the table is nothing more than the closing price for that particular stock, namely Amazon, in that particular day. So this is interesting, since it's very flexible. It allows you to perform a few data transformation in just one line of code. A natural question that might rise now is, well, it's fine, but then this representation is fine, but look, in the original data frame, I had 2 columns, namely close and volume. So in this way, I'm completely missing up the information related to volume. How can I add that information to the new data frame? You have 2 strategies here. So the most direct one is to pass a list of values inside the pivot. So we are going to pass the close and the volume, so that now if you run the cell, you get a new data frame where you have an innermost index for columns defined by the symbol and an outermost index defined by the original columns that you have in your data frame. But life is easier in our example, since we have just 2 columns. So if you want to basically translate the original information into this pivoted table, you can avoid the specification of the values, since actually you are telling Python to pivot the original data frame with respect to an index and a column, and automatically Python is going to take each single remaining column from your original data frame and is going to pivot them. Since here we are just two columns, namely close and volume, this operation that I'm gonna call I'm gonna store into the variable pivot underscore df underscore new. Let me say, if you pay attention now, without the specification of the values, I'm going to get exactly the same result. And the motivation is, again, is pretty simple. In this case, we have a data frame that is made by 4 columns: date, close, volume, and symbol. If we specify date as index and symbol as columns, and we don't specify anything for values, as in this case, then automatically Pandas is able to recognize that you want basically to pivot all the remaining columns from the original data frame, namely close and volume. Pretty cool, right? In just one line of code, you got a nice pivot table that it's readable and it's easy to share with your colleagues. Okay, the same, since I like to give you not just way to produce the table, but I want to give you also tips and tricks on how to produce such result. I'm going to tell you also another method that actually mimics the pivot one, but I would say it extends the pivot table. And this one is the unstack method. The unstack is pretty, I would say, underrated, but is actually pretty useful, especially when you use when you are dealing with data frames that present a multi-index level. So let me say like this. I can obtain the same result that you see, let me say, with this one, with the close. Let me add the values here, and I'm going to go back to the original example that we did with just the closing price. So we can get the same result by using the unstack method. So a natural question is, when should I use the unstack in place of the pivot? So the pivot actually is not recommended when you are dealing with multi-index data frames. And better performances in presence of multi-index multi-level index, sorry, are obtained using the unstack method. And hence, we should use the unstack method when you wish to pivot a level of the hierarchical row index to the column axis, producing basically a reshaping data frame with a new innermost level of column labels. Putting in more simpler terms, you can see a stacking. The stack is nothing more than taking a row level of your data frame, and putting that level as column of the new data frame. It's as simple as that. And I believe that an example speaks better than thousands of words. So to give you an idea, let's pick the original data frame. And you see here that we have an index basically that is numeric and is an increasing index. It's pretty easy, a pretty easy index. So I can set, as a toy example, a new index for my data frame. And in particular, I'm going to set the date and the symbol. And I store this into a variable called another underscore df. Pretty easy. Remember, this is now a multi-level index data frame, since we have two index here. And therefore, the question is, how can I pivot that particular table? Well, I can use unstack, as I said before, and therefore I'm gonna pick this another df, and I'm gonna unstack the another df by specifying the level I wish to move from row index to the column index. So for instance, since I want to basically get the same result as here, I'm gonna move the symbol from the row to the column by simply specifying level equal to symbol. And I can print the first 10 rows just to give you an idea of what's going on. So here I'm getting actually the closing, but also the volume, since I'm bringing back also the volume. So if you want instead just the closing, you can actually remove it. And well, let me drop that column. It's not necessary, but just to be clear with you, I'm gonna drop that column and I'm gonna stack with respect to the closing price. Here we go. So here you got exactly the same result as the one that you obtain using a pivot table. Again, I like the way in which Pandas work, because it allows you to perform the same operation in multiple ways. And but there is a substantial difference between the pivot and the unstack. The pivot is recommended, especially when you work with data frame that present a single row index, whereas the unstack perform the best when you have multiple row index, as in this case that we call another df, where we have the date and the symbol as row index. Okay. As the further method that I want to share with you is the pivot table. I would say this is the most popular method inside the transformation class, since I would say it is the most practical one. I guess everybody in his or her daily life use a pivot table. If you are using Excel and you spend a lot of time with Excel spreadsheet, possibly you are working with pivot table. And therefore, the interesting fact is that you can produce such nice tables with just one line of code using Pandas. And there is also a substantial difference between a single pivot table with a pivot that we saw before. The pivot method is actually used to reshape the data so that you are actually looking at the same quantity with different aspects. But the pivot table goes beyond that particular case, since it allows you to actually perform transformation on the data. And think about a pretty simple example. Your boss come to you and say, well, I need a report in which I want to understand the average price for each single stock in our portfolio. That's a pretty simple question. And you can obviously use Excel to do that if you have a file, a CSV file somewhere. But if you are using Python, you are much more flexible to perform that kind of analysis, and you can use a pivot table method coming from Pandas. And the syntax goes as follows, basically. So you have a function called pivot table, which requires several arguments. The data, in our case, is the original data frame that we define df. And then again, we have an argument called values, which is nothing more than a list of columns we wish to aggregate. So in our case, it's nothing more than the close. Then you have the index. Again, is nothing more than the column from the original data frame you wish to have as index of this new table. And if I remember correctly, it should be date. And then we have a new argument for this function called aggregated function, denoted as aggfunc, in which you can pass an iterable of function you wish to apply on the values column. So for instance, as I said before, I want to get the mean of for each single stock observed in our portfolio. So I'm going to specify to this argument just the string mean. And Pandas is smartly enough to understand that this string mean is associated to the computation of a mean. And therefore, all the dirty job is done for you by Pandas. Okay, so this is basically pretty much the syntax. And I'm going to store this into the variable pivot table df. And that's it. I can now print the first 10 rows of this table. So here, actually, we are getting the mean for each single date with respect to the close column. Do we really want this? If you think about, this is quite misleading, right? Because if you remember my question, our boss come to us and say, well, I need a report that tells us for each single trading day, not for each single trading day, but the average price of each single stock inside our portfolio. So actually, here, we are not performing exactly the instruction, since here we are just saying, well, I'm computing the mean of the portfolio with respect to the closing price for each single trading day. I don't want that. Instead, I want to pass as index the symbol, the symbol, and as values the close price. And now, if you try to run this piece of code, you will see that we got exactly what we wanted, namely, for each single stock, its average price in the last 6 months. And this computation was made thanks to the specification of the aggfunc argument. Again, pretty straightforward, isn't it? It's just with one single line of code, you have produced this table that obviously in this toy example that I'm showing here in this live session, is pretty easy. But think about having a more complex data frame and the result is gonna stun your audience, because with just one single line of code, you produce a nice table. Okay, so the interesting fact about this function is that you can pass an iterable of function that you wish to aggregate. For instance, I can pass not just the mean, but I can say, well, I'm gonna compute the mean, the standard deviation, denoted as STD. Let me say the max and the mean, and that's it for the moment. So if we try to run this now cell with 4 different aggregating functions, we get this result. Actually, we get 2 rows, namely the 2 stocks in our portfolio. But the interesting fact is that now we have an inner an innermost index for the column that stands for the closing price, and an outermost level in your column index, denoting the method applied for each single column, namely mean, standard deviation, max, and minimum. And in this way, you can actually build a nice table for your boss, and he's gonna be pretty happy of your work, since in just one table he's able to understand the distribution of the closing price in that particular time window, and he's gonna get the mean and the standard deviation computed for each single symbol. In our case, Amazon and Tesla. I have to say I love this pivot table method. It's pretty direct and pretty simple to use. But there exists a more flexible method that can be employed for Panda user to produce the same table, and this is the group by. So with the term group by, we refer to the process of basically splitting the data into groups, applying a function to those groups, and then combining together the results that we obtain from each single group. And if you think about, in our case, a group by means actually splitting with respect to the symbol. Then you basically aggregate with respect to the mean. You compute the mean for the mean price, closing price for each single symbol, and then you combine the results, right? So if you think about, this is nothing more than the steps that in the back end the pivot table is performing for you. So if you wish to have more flexibility and you want to manage actually your work, the group by is the right choice for you, since actually perform all the operations in the back end for the pivot table. And in this case, actually, you can control each single step, and therefore is more flexible and much more powerful, in my honest opinion. And just to give you an idea, the group by method in Pandas mimic the group by that is performed in the SQL language. And typically in SQL, you are going to use the keyword group by to aggregate a quantity with respect to a few identifiers. If you are familiar with SQL and you want to dive more into that language, in Cloud Academy we have a few learning paths. So I strongly encourage to check out our content library to look for SQL learning path. They are really well written, and I strongly encourage to give you a look. Okay, let's go back to our side, and we can basically apply the group by method. And the syntax is pretty simple. I'm going to actually apply to the data frame a group by. It's not PDF, but it's DF, sorry. It's a group by. And the group by actually, as I said, perform three operations. It's going to split the data with respect to a column, in our case with respect to symbol. So I'm going to split the data, original data, in groups with respect to symbol. And then, as I said, I'm going to actually take the column I'm interested in our case is closed, and I'm going to apply a function to that particular column. In our case, we want to aggregate with respect to the mean. If you try to run this cell, and let me store this into a variable called group df, just to be clear. Look at that. I'm going to get a Pandas series where I have Amazon and Tesla as index, and the two numbers exactly are the same that we got with the pivot table. And if you want to get a result that is similar to the one that you saw before, you just need to apply the two-frame function that is nothing more that is going to perform a forcing of the series to be a Pandas data frame. And here is the result. You get exactly the same result as the one that you see before. And remember, you are using a group by method. And the group by, again, is used by the pivot table in its backend to produce the same table. So the natural question is, why should I use the group by? Since I have the pivot table that is pretty nice, concise, well written, why should I use it? Well, I have to say that you can perform several steps that the pivot table is not allowed to do. For instance, you can apply different metrics for different columns. What does it mean? It means that I'm gonna basically pick the same structure here. So I'm gonna group by with respect to the symbol. And now, instead of taking into account, namely, just the closing price, I'm going to aggregate with respect to two columns, namely close and volume, but to those columns, I'm going to apply different metrics. So let me say that to the close column, I'm going to apply the mean and the median, and to the volume, I'm going to apply, let me say, the max. This is pretty straightforward in the group by, and the syntax goes as follows. I'm going to pass a dictionary, where a Python dictionary, obviously, where I'm going to pass as key the column I wish to transform, namely the close, and as values, I'm going to pass the function I wish to apply to that particular column, and I say the mean and the median. And then I have also another column, as I said, the volume. And in this case, I'm going to apply, let me say, a max. In this way, I don't have to care about which column I wish to apply that particular function, in our case, the mean, because I'm going to manually manage each single function with respect to each single column. And this is pretty straightforward. And I'm going to store this into df new 00. Sorry for the name, but it's fine. Just need to be used for illustration. And here we go. Look at here. You have, again, an innermost level index and an outermost level index. The outermost is the most interesting one because for the close you have two columns and for the volume just one, since, again, we have specified in this dictionary that particular structure. And then, if you pay attention, you have that the close has applied the mean and the median, and the results are obviously different, luckily. And I really like this flexibility, since if you are working with complex models, this allows you to perform more advanced data analysis with respect to specific quantities. And actually, you can aggregate in a simpler way without the need of specifying all those Python dictionary. So you can take, for instance, the close column, and you aggregate with respect, say, to the mean and to the median. And you get exactly the same result that you see here. So it depends on your application. I don't have a strong opinion on that, but typically I prefer to use a dictionary, since the dictionary allows you to be more flexible with respect to different columns. And this is pretty much So I'm ready to answer to your question now, if you have. Okay, so there is a question, and the question is, can we fill values directly inside the pivot table if I have none? This is an interesting question. So thank you for asking this. Let me go back to the pivot table. So if I have understood correctly your question, you are assuming that your data frame has some null values, and if you have null values, you can actually explicitly tell Pandas to fill those values. Fill value should be fill value. Yes, I guess. Yes, here it is, fill value. And you basically specify that if there is any missing value, you can impute that with a 0, for instance, or you can be more sophisticated and say, well, I'm going to use a mean. I'm going to compute, let me say, the average mean of the clause if there is a missing value for the closing, and I'm going to impute that null as the mean value. This makes sense, and well, you have to import NumPy since I'm using here NumPy, and this would work. Let's try. It's not num. Oh, well, this is a typo. NumPy as NP. Here we go. So actually, I'm not imputing anything in my data frame since all the values are known. So there are no missing values, luckily. But if you have missing values in your data frame and you wish to impute those values with a mean, you can easily, with just this simple argument, you can fill those values. So then there is another question. What about if I have multiple columns, such as 5? I guess I don't have so much context to answer to your question. I try to understand it. I guess because now possibly I have understood your question. So here I was trying to pivot with respect to close and volume. And then you are asking, well, suppose that I have also other columns that I don't want to pivot. My strategy is to actually use the drop method. So actually you're going to drop the columns that you don't want. Okay, you pass a list of columns, obviously. And actually you have to specify the axis equal to 1, namely that you are going to drop all the columns. And this is a possible strategy, obviously, but in case I have not answered to your question, please raise your voice, and it will be a pleasure to answer to your question. I guess not. Okay. I guess we are done, Francesca.
Sounds good. Thank you so much, Andrea. That was really a great session. So before we part ways, just a couple of reminders. You will receive the recording of the session as soon as it is available. Please fill out the end of webinar survey. Your feedback is extremely helpful in understanding what kind of webinars you'd like to see more of. And if you missed the previous episodes of the Pandas Like a Boss webinar series, you can find all the previous sessions on our website, specifically on cloudacademy.com/webinars. Just scroll down and you'll find episode 1 and 2. And of course, we will add episode 3 there as well. And you can also find the sign up link for episode number 4, which will take place on April 14th. But don't worry, because in the follow-up email that you will receive, you will also find the link to sign up for that session. Again, thank you for joining us, and until next time, goodbye.